Good morning, everybody. And thank you to the organizer to give me the opportunity to be here with you. So I'm Debora from Thermo Scientific. I'm the responsible of the Center of Excellence in Breda for PFAS analysis. You cannot hear me. Usually I have a loud voice, but anyway, I can take the microphone. I like to stand, sorry. Yes, please. Thank you so much. Yeah, I like to present standing, because if not, you will see half of my face. Okay, so today I hope to get you setting a new horizon in the analysis of PFAS and giving you a bit of, a bite on each application that we can perform with high resolution accurate mass from Thermo. As my colleague has already described, PFAS is really ubiquitous and it can come from different sources and go into the environment, not only in water, but even soil and food and feed. And depending on the workflow and of the need of your laboratory and the goal of your analysis, we can offer really a great panel of a solution. So today, as I stated at the beginning, I will focus on high resolution accurate mass, but don't forget that Thermo offer a great triple quads and moreover, and it will be at the end of my presentation, to some great software to do not only targeted, but untargeted and unknown determination. And it will apply also to PFAS. It is our new technology. The new Orbisharp Explorer series had been launched in 2021, and it is really engineering, thinking, and really gives some benefits, thinking to the applied market. Applied market is a big market for us, and the new technologies have been think to address all the requirements of your laboratory as robustness and ultimate sensitivity, speed. As you can possibly know, I see some face that already use our technologies. So the resolving complexity of the matrix, as our colleague is perfectly going over with, and the resolving power of high resolution would help you not only resolving the complexity in weird matrices, but in identify components in a reliable and excellent mass accuracy. Don't forget the robustness and the sensitivity of the instrument. Coming back to the low maintenance and robustness and the ability to stay low in mass accuracy over the time, the new with the speed that Orbisharp Exploris gives you, you can combine different approach in analysis, so different scan mode. I would start from voice of customer. And that it would be my fil rouge in this presentation. So going from targeted to untargeted approach in PFAS analysis. Aerolab is one of our key customer and published with us a case study underlining the use of the resolution and how the high resolution can overcome some false positive, some challenging in difficult matrices, and I encourage you to read through this application note to discover more. PFAS is not only mass, guys. So we know that PFAS is in high broad range of components, starting from the low chain C4, maybe C2 sometimes, going to C13 or 14 or 18 in food matrices. It is causing challenging for your HPLC if you are not ready. Our colleague is perfectly described the challenges coming from the solvent. We use as well a delay column, but Vanquish can offer you more. We are ready with the user-defined injection program to inject pure methanol, even high concentration, even high volume injection, and to do sandwiching, zebra, different grading delay volume to allow great peak shape of your eluting and maintain in your vial even the C18. Quantitative workflow. Orbisharp is not only unknown, is not only a research instrument, it is meant and really designed to be your bench instrument. See that the footprint is really reduced. If you have in your lab the former QE, you can see that here we have really boost in the footprint, and we are able to analyze all the panel of PFAS and more. This is to stick to the UE regulation 2022 down to sub PPT level. And how we are doing it with full scan targeted SIM. Full scan to maintain the retrospective purpose of the high resolution, targeted SIM to reach ultimate sensitivity when needed. Here, few example, really, I say a bite just because I will bite all the applications that we have, from 0.1 to 10 nanogram per liter to octanomagnitude calibration curve of PFAS. Even the low calibration point is really reproducible over the time, over the run, thanks to the previous mentioned mass accuracy that Orbisharp Exploris can give you, even in a long run, in a long validation run. Most challenging one, due to contamination and peak shape, we can obtain, thanks to Vanquish front end, a good peak shape from PFBA and a nice reproducibility. I will go fast because my colleague was really effective to present you the new regulation in food of the Food Drug Administration. We have get our hands also on the food matrices, and I just want to show you the powerful of high resolution comparing up a spike in solvent, pure methanol, and down a spike in tomato. That is not the easiest matrices ever. It's acidic, so it's not between the fruit and vegetable is not the easiest one. And you see that taking the exact mass in full scan, it's just an analysis in full scan in this case, because Food and Drug Administration is quite high level compared to the level that are requested from the URI regulation, and even more in the Nordics. Recently, we were asked to analyze some weird matrices. We encountered some customers that want to analyze active carbon, but their purpose really fit on our proposal. So they don't want only to quantify, but then they want to discover what is inside their sample as PFAS. So they get us to sample, and we quantified the components that we found in our target list, and then we did a retrospective analysis. If you will go through after this meeting to the customer application note with Dr. Peruzzo, you will see that even in their case, retrospective analysis was really a key feature. So acquiring in full scan and target sim, you can really rerun the same analysis that you run with your targeted approach in retrospective. What it means? That you can get, sorry, I don't know if I have a pointer. Yes, our software compound discover and reprocess the data. Investigate new component, and what it will give you. Compound discover is software that is a deconvolution software, and especially for PFAS, you have some key feature that other software cannot give you. That is obviously a targeted, great mass list curated with MS to the second, but also a bit more. So this one, leverage Kendrick's and standard mass defect. It means that inside compound discover, you can find some clustering, taking in account the length of, let's say, the same portion of the molecule, like PFAS it is, because it's a repetition of CF2. So you can search in a library, you have the feature to grid down your entry, Kendrick, leverage, curated library with MS to the second, and built-in with a visualization tool. And a ready-to-go workflow. You have not to invent the wheel. We have already experience in unknown, in untarget workflow with compound discover. We have some laboratory that already performed this workflow on their sample. One is obviously Massimo Peruzzo. And you have searching mass list. First, we have a mass list. Let's search in this. And then detect compound with fluorine and predict composition with fluorine. It means that it do not only search in mass library, but it predict eventually something that is not in the mass library that contain fluorine and sometimes bromide. And then comparison with mass to the second acquisition. Because if you do full scan, if you do targeted SIM, you have all the spectra behind with data-dependent acquisition. And coming back to the active carbon, we were able to take some more insight in the sample that the customer gives to us, and we identify some other components that were not in our target list. Our target list, for example, in in the triple quads contain some telomer, but as it was not the purpose of this demo, for example, telomere was not inserted in the targeted list, but we detected anyway. So Arbiter can give you quantitation, easy and ultimate, retrospective and target screening and unknown capabilities. And then when you found your other component that you do not suspect that was in your sample, maybe came back and quantify them. Open for questions.
Thank you. Any question?
I am close. Oh, thank you. So congratulations for this very interesting presentation. Just a curiosity regarding the reproducibility of the results that you can get by performing the retrospective data analysis. If you can comment a little bit more.
What do you mean as reproducibility?
I mean the precision in some way of the data that you can get performing several times the same retrospective approach on the same samples, for example.
On the same sample. So it depends on the workflow. Obviously, the workflow setup now is meant to find fluorine component. So you can really get very precise results if you are searching and screening, so really for fluorine containing component. If you change a little bit the workflow, easy because it's a drag and drop software, you can get even more results on your sample. So the reproducibility, if you work in the same workflow, will get you the same results. Obviously, the amount of time that you spend, for example, in getting the target one, so search in library is easy. When you have to read down a really unknown, you need more node and you need to investigate further. So, but you have all the tools in Compound Discover to really enrich your basic workflow and to get more results. In this case, it could be different because it depending of the operator and of the level of the person that is working on the software itself, because don't forget, it is a software. So it is the person that have to make the node and have to discover how to go through and get back with the formula, especially for the unknown, that makes a difference. Still.
Thank you again.